Welcome to my daily coding tutor YouTube channel. In today's topic, we are going to be discussing on the difference between the compile time and runtime polymorphism in details. Polymorphism in object-oriented programming, which is the OOP, allows methods or functions to behave differently based on the context. Polymorphism in object-oriented programming allows objects to be treated as instances of their parent class while still maintaining their specific behavior. Now, there are two main types of polymorphism, which are the compile time polymorphism, also known as the static polymorphism, and the runtime polymorphism, also known as the dynamic polymorphism. Now, let's look at the first one, which is the compile time polymorphism. Compile time polymorphism is achieved when the method that needs to be executed is determined at compile time. This is also known as static binding or LA binding. Compile time polymorphism, it occurs when the method to be executed is determined at compile time, and this is typically achieved. This is achieved using the method overloading and the operator overloading in some programming language like the C++. The method overloading is the multiple method in the same class with the same name but different parameter list, like different types, numbers, or sequence. The compiler determines which method to invoke based on the method signature, while the operator overloading allows operator to be redefined to work with user defined data types. Now, let's look at the method overloading. The method overloading has a multiple method in the same class with the same name but different parameter list, which is a different number, types, or order of parameter. Like I said before, the compiler determines which method to be called based on the method signature at compile time. Now, let's look at the example in Java. We have Java class math operation, open braces, comment, method with two parameters, int add, open bracket, int a, int b, close bracket, open braces, return a plus b, column, semicolon, close braces, comment, method with three parameters, int add, open bracket, int a, comma, int b, comma, int c, comma, close bracket, open braces, return a plus b plus c, semicolon, close braces, close braces. The next one here is the public class main, open braces, public static void main, open brackets, string, open bracket, close brackets. You have the args, or you call it args, close bracket, open braces. You have the mass operation object, obj equals to new mass operation, open bracket, close bracket, semicolon. System.out.println, open bracket, obj.add, open bracket, 5, 10, close bracket, semicolon. Comment, calls add, open bracket, int, int, close bracket. You have the system.out.println, open bracket, obj.add, open bracket, 5, 10, 15, close bracket, semicolon. Comment, calls add, open bracket, int, int, close bracket, close braces, close braces. Now, let's look at the key points. The method to execute is known at compile time. It improves performance as there is no overhead for resolving the method at runtime. It cannot be used for achieving dynamic behavior. Now, we are going to look into the second type of polymorphism, which is the runtime polymorphism, also known as the dynamic binding. Runtime polymorphism is achieved when the method to be executed is determined at runtime. This is also called dynamic binding or late binding. The runtime polymorphism occurs when the method to be executed is determined at runtime. This is usually achieved through the method overriding using inheritance. The technique used to achieve this is method overriding, supported in language like Java, C++, Python, etc. Method. Let's look at the method overriding. Method overriding is a subclass provide a specific implementation of a method already defined its superclass. The overriding method in the subclass is called at runtime based on the actual object type. This method provide signature like the names, the run types, and parameters remain the same, but the implementation differs. The subclass provide a specific implementation of a method already defined in its parent class. Now let's look at the example. We have Java class animal, open braces, void make sound, open bracket, close bracket, open braces, system.out.println, open bracket, animal makes a sound, close bracket, semicolon, close braces, close braces. We have class dog extend animal, open braces, at override, void make sound, open bracket, close bracket, open braces, system.out.println, open bracket, door backs, close bracket, semicolon, close braces, close braces. We have the public main class, open braces, public static void main, open bracket, string, open bracket, close bracket. You have the args or args, close bracket, open braces, animal, my animal equals to new dog, open bracket, close bracket, semicolon, comment or casting. My animal dot make sound, open bracket, close bracket, semicolon, comment, calls dogs make sound, open bracket, close bracket, method at runtime, close braces, close braces. Now let's look at the key points. The method is executed to determine at runtime. Achieve using method overriding. It is achieved. This method is achieved using method overriding. It enables flexibility and dynamic behavior. Slightly slower than compile time polymorphism due to the runtime method resolution. This support upcasting and late binding makes it useful in large system and framework. Now let's look at the difference between compile time and runtime polymorphism. The difference between compile time and runtime polymorphism. We have the feature compile time polymorphism, runtime polymorphism. Now, under the binding, the compile time bind has early binding, also known as the static, while the runtime polymorphism has late binding, also known as the dynamic. Let's look at the method selection. Compile time determined at compile time, while the runtime polymorphism is determined at runtime. Techniques used. Compile time use method overriding and method operator overloading in their techniques. That is the technique that is being used, while the runtime polymorphism use method overriding. Performance. Compile time polymorphism is faster, more faster, no runtime overhead, while the runtime polymorphism is slightly slower. It is slightly slower. Runtime method due to runtime method resolutions. Flexibility. Compile time polymorphism is flexible, is less flexible, while the runtime polymorphism is more flexible. Used in. Compile time is used in scenarios where method behavior is fixed and known at compile time, while the runtime polymorphism is used in a scenario where behavior needs to be determined dynamically at runtime. Let's look at example languages. Example languages. It is the runtime. The compile time is used in Java, C++, Python, the function overriding in some cases, while the runtime is used in Java, C++, Python, and other OOP languages. So this is where we are going to stop for today. In conclusion, both compile time and runtime polymorphism are essential features of OOP, allowing for code usability and flexibility. Compile time polymorphism is faster and resolved at compile time, whereas the runtime polymorphism provide dynamic behavior, making it more powerful in scenarios requiring method overriding requiring method overriding. So this is where I'm going to stop for today. Thanks for watching our video. Like, share and subscribe to our YouTube channel. Bye.